So now we're on to question 6, which is another nice creative question involving a graph. So we have this candle heat of 12 centimeters in height, and we have a graph of the height of the candle decreasing over time. So the first part, we are asked, why is the initial part of the graph not a straight line? So the graph starts by curving down, and then it's a straight line. Well, if we look at the candle itself, you can see that the candle is a cone at the top. So the cross section of the very tip of the cone is narrower or smaller. So it will burn through that part more quickly. But as it gets down further, the cross section widens out and it doesn't burn through that as quickly. So the height will not decrease as quickly. So we can say something like this: the cross-sectional area of the candle is less near the top of the cone, that the shape was a cone at the top, and so the candle burns and decreases more quickly than further down the candle. So you really have to think about the context of the question and what the graph means in that context. Okay, now on to part B. We're saying the straight line portion of the graph has the equation h equals mt plus c, which is, you can recognize as a standard equation of a straight line. And we want the rate of change of the graph, which is represented by m. So a rate is something divided by something. In this case, it's going to be the height or the change in height divided by the change in time. So for this, we need to identify 2 points on the graph, and they're the end points of the straight line segment. At the end is a time of 23 hours and a height of 0 centimeters. So we'll use that. We also need the height of the candle at the beginning of the straight line segment, which you can see is 7 from the diagram above. So at 3 minutes, so 3 hours, it has a height of 7 centimeters. So we are going to use the 3, 7 and the 23, 0 to work out the rate, centimeters per hour. So gradient is vertical change divided by horizontal change. The vertical change is 0 take away 7. It's a decrease over time, so it should be the 0 should come first. We should get a change in height of minus 7 centimeters, and the time is 23 take away the 3 hours. We didn't start the straight line decrease until 3 hours had passed. So simplified would be minus 7 twentieths. Now in the marking scheme you could have just said 7 twentieths. It is a change of 7 twentieths centimeters per hour, although it is nice as a decimal, 0.35, and units. You need to have units. Minus 0.35 centimeters per hour. And that's part B done. Now we're on to question C, where we need to work out the height of a candle if it's going to burn for 40 hours. So the company is making the candle longer. So let's look back at the graph before and see how long it took before, 23 hours. So the first thing we will do is work out how many extra hours they wanted to burn for. 40 take away 23, so 17 hours. So now we need to work out how much candle would be burned through in 17 hours. And that'll be the extra height of the candle that we need to have extra. Let's look at the answer to part B, 0.35 centimeters per hour. So in 1 hour, it decreases by 0.35 centimeters. How much would it decrease by, or need to decrease by, in 17 hours? Well, we'll do 17 hours times 0.35 centimeters per hour. And this is a standard rate calculation. So you'll always either multiply by a rate or divide by a rate. In this case, we're multiplying by the rate, and you can see that the units are compatible. So hours multiplied by something per hour gives you whatever it is per hour. Same principle behind distance, speed and time, for example. This is going to give you 5.95 centimeters. That's only the extra candle. We'll also get the total height of the candle by adding that on. So original candle was 12 centimeters tall. 12 plus 5.95 equals 17.95 centimeters height of the candle.